Let us discuss about bridge rectifier. So this is the circuit for bridge rectifier. So here I am using 4 diodes. In the last lecture I have explained about center tap transformer based rectifier. So where I was using only 2 diode, but here I am using 4 diode. Instead of 2 diodes, I am using 4 diodes. D1, D2, D3 and D4. The input supply is connected here. So it is phase terminal and neutral terminal. RL means it is a load resistance. Now let us see the working principle of bridge rectifier. So bridge rectifier working during positive half cycle. So if I apply a positive half cycle, during positive half cycle, your phase will become a high potential because phase is greater than 0. So phase will become high potential. So plus represent it is a high potential, but your neutral is always 0 potential. So it is 0. Diode D1, that is first diode, anode is connected to high potential. So it will become forward biased. Third diode cathode is connected with the low potential, so it is forward biased. So during positive half cycle, D1 and D3 will become on, and look at D2 and D4. D4 cathode is connected to high potential. Cathode high potential means it will become automatically reverse bias. Look at the anode of second diode, it is connected to low potential, so it will act as an off switch. So these two diode will become on, will act as an on switch, and D2 and D4 will act as a off switch. So the current is always flowing from higher potential to lower potential. So this will be the current direction. It starts from phase, it flows through D1 and it reaches the load, it reaches the neutral terminal. Now look at the current direction. Current is coming down. So whenever the current flows through the resistor, there will be a voltage drop across the resistor, that is represented by V030. So this is the voltage drop across the resistor due to positive half cycle. Now consider now if I apply Vm voltage, I am getting the same magnitude Vm. Neglect the diode drops. During negative half cycle, if I apply negative half cycle, negative means your phase goes to negative. So phase potential is negative, neutral potential is still 0. So your anode, first diode anode is connected to negative. So automatically it will go to reverse bias. Look at the third diode. Cathode is connected to low potential. So here D1 and D3 will become off. D1 and D3 will become off, and D2 and D4 will become on because this anode is connected to 0 volt and cathode is connected to low potential. So automatically this diode will become forward biased. So D2 and D4 will become on, but D1 and D3 will become off or reverse biased. So now the current flow will become 0 is greater than negative, so higher potential to lower potential. So current is flowing from 0 to negative potential. So 0 is higher value when compared to negative. Current is always flowing from higher potential to lower potential. Now look at the current flowing through this resistor. Again the current is coming down. So you will get the positive half cycle or the voltage waveform like this. So the input voltage is negative, but the voltage across the load is positive. So there is a rectification process. So it is known as Fourier rectifier because we are getting the output in both the half cycle, during positive half cycle as well as negative half cycle. Same Vm I am getting across the load. So this is a comparison of 3 configuration: half wave, full wave using center transform, bridge type configuration. Almost the circuit is similar. So in the Fourier rectifier in bridge type I am getting the maximum output 2 Vm by pi. So here they are represented 2 Vm by pi. This Vm, it depends upon the secondary output, that is it depends upon the turns ratio, center tap turns ratio. So that's all about the full wave rectifier. Thank you.